So we're going to find the interval of convergence for the series. Remember that we always have to check our endpoints. So this is not a geometric series, so I'm going to use the ratio test. So I'm going to have the nth plus 1 term over the nth term has to be less than 1. Okay, so we're going to have the nth term. Remember that is dividing by the nth term, which is the same thing as multiplying by the reciprocal. So I can rewrite x to the n plus 1 as x to the n times x. The x to the nth are going to cancel, and so are the 2 to the n power. Okay, so since n is going to infinity, I don't have to worry about the x. I just need to know what this is doing. So as n is getting closer and closer to infinity, this is getting closer and closer to 1. So I'm just left with the absolute value of x over 2, and we know that this has to be less than 1. So my interval of convergence is between -2 and 2. So now I have to check the endpoints. So at x equals to -2, I'm going to substitute that into my x value. So I'm going to have -2 to the n times 2 to the n. So this is actually an alternating series because at -1, I can separate them as -1 to the n times 2 to the n. Notice that my 2 to the n's are going to cancel. In this series, it's just going to diverge. So it's not, the -2 is not included in my answer. So at x equals to 2, I'm going to go ahead and substitute that into my series. So notice my 2 to the n's are going to cancel, and this is just going to diverge as well. So my interval of convergence, it just goes from -2 to 2.